Okay, so since we do have a lot of kids out today, I do want to kind of just say what we're doing in here. What we've just talked about, ladies and gentlemen, is we've talked about three concepts. We've talked about, first of all, if we have a segment, see this segment right here, this black segment, we'll call that segment AB. If C, you see that point C right there, we've defined that point C to be the midpoint. And what is a midpoint of a segment? A midpoint of a segment is a point that creates two congruent segments, little kind of baby congruent segments. So if you notice that A to C is going to be congruent to B to C because C is the midpoint. And then after that, what we did is we defined what a bisector is. The purple line, the red line, and the blue line are all bisectors of this segment AB. And the reason why they're bisectors is because they go through the midpoint of segment AB. You guys see that? Okay, live action kids. Just give me a thumbs up if you see that. Just okay. Any quick. Okay. So what we're going to do now, ladies and gentlemen, is we're going to construct a perpendicular bisector of a segment. We're going to construct a perpendicular bisector of a segment. And it's a very, very, very simple construction, okay? So I have live action kids. I'm going to do it on my online tools, and then my live action kids will do it just probably with the physical compass is good, okay? All right, so here we go. So let me go back to your class here. We go to Schoology, courses, second period. Open up, please. By geometry tools. And I always have these construction tools here. Okay, so you can always. All right, got my construction tools pulling up. Yada, yada. Okay, so first of all, what I want everyone to do on your white piece of computer paper is let's just construct a, do this here. Let's just construct a segment, okay? And we'll do it horizontal pretty much with the page. Okay, it doesn't have to be. Now, wait, by the way, put it in the middle of your paper. I apologize. Put it in the middle of your paper. Yep. So, because we're going to need to go above it and below it. So if you need to switch it, that's fine. So put it kind of in the middle of your paper. Sound good, guys? So I'm going to put mine about right here. Okay. Now, let's call that segment AB. And the worst part of the online geometry tools is the writing utensil is just trash. So there is, but it's so bad. Okay, it's just so bad. But let's see if I can do it. Okay, so there is a pencil here, but look how bad it is. So this is A. As long as you don't lift the pencil up, it's okay. But as soon as you lift the pencil up, it's just gone. Okay, y'all see that? So there's AB. Any questions with that, guys? Okay, now, next thing we want to talk about is, okay, so what we want to do is we want to create the perpendicular bisector. So this is a given, okay? So the first thing you have to talk about is your given, okay? Your given, ladies and gentlemen, is you have to have that. Now, the nice thing about this construction is that's the only thing we need to be given. We don't actually even need to be given the midpoint. You guys see that? So what we're going to do is we're going to construct and this is kind of an perpendicular. You guys know the symbol for perpendicular? Upside down capital T, right? We're going to construct a perpendicular bisector. Okay? I know it's going to take me a second to write because this pen is so bad. I learned that if you don't lift your pen up, it's good. Perpendicular bisect. There. Okay, y'all see that? So this is a perpendicular bisector. Okay, so what do we do first? Well, the first thing we do, and hopefully this won't get in the way of my, I'm going to just erase all of this just because I need room, okay? All right, so the first thing I'm going to do is I'm going to take, and you guys go ahead and construct yourself. Now, here's a hint. I'm not to pick on Esme, but Esme is going to be, you won't be able to fit that perpendicular bisector. So let me see if I see a good one. And this is all Mr. Roden's fault. Make it kind of short, all right? Let's see here. And you want to use the whole paper. Don't make it too big. So I would say make it about 2 or 3 inches, okay? In the middle of your page, okay? Sorry. If you want another piece of computer paper, obviously we have more. So don't stress, okay? I'd say 2 or 3 inches. What do you got there, Sophia? Yeah, let's see. A little too long. No, I like Nicole. I really like Nicole. Can I see yours, Nicole? I like this length. I really like it about this. This is really good. Okay, right in the middle of the page, about this long. You'll see why it won't work if you make it too long. It will work, but first of all, your compass probably won't stretch that far, and you won't be able to fit it on the page. Okay, so it's not that you have to use it. It's just that the paper is going to have kind of a. So make it about this length. Yeah, Reese. Test good. Oh, test good. Yep. I'd even make it shorter. Yep. Okay, you'll know. Now, notice we do not need the center point, so we don't want to put any C's in there. We're going to make our own C. Okay, now how are we going to do this? Now, what's probably going to happen is if it's too long, you're going to see why it's too long. So the first thing we're going to do is we're going to come over and we're going to put our needle on one of the endpoints. So I'm going to put my needle on A. I'm going to open my compass up so it's over halfway. And that's just kind of just an estimate, right? Okay, so I'm going to open up my compass that it's over halfway. So that's about over halfway, right? Okay, approximately. Now I'm going to lock my compass and I'm going to make a semicircle. A semicircle is half a circle, or even more if you want. Don't make a full circle, but I'm going to make about a semicircle. So you can see this is where if your segment's too big, it goes off the screen. You guys see that? Let me see if I can make this smaller. No, my compass. Trying to make this a little smaller. Okay. All right. Y'all see that? Now, the next thing I'm going to do is I'm going to take my compass. I'm going to move it over. I'm going to put the needle on B. Y'all see that? And then I'm going to keep that same setting. I'm going to keep that same setting, and then now I'm going to make a new semicircle I'm going to keep that same setting I did, and I'm going to make it's going to look something like this. Y'all see that? Move it off here. So this is what we want. We want that design. So I'll give you a second to do that. The key is you got to keep your setting the same. Okay, you with me on that? Hold on. So give you a second. Yeah, these compasses, most likely, if you can't do it, it's not your fault. It's because the compass slides. Okay. I see Kaylin. Looks good. Yep. Okay. Tess is getting it. Eliana's getting it. Okay. Yep. And what I find is certain kids are really good at constructions and certain kids struggle. I am a struggler with constructions. Okay. It has nothing to do with my smartness or ability to think. It's just because my hand is not as steady as it should be. Right? Okay. So, and just going around the room, I see a lot of really good things here. So just for the kind of the sake of this, let's label these two intersecting arcs here. So this arc right here, let's call this D. And let's call this intersecting arc down here E. Okay? Now remember, what our job is to figure out how to get a perpendicular bisector. Now here's the easy part. Now you just take your straight edge and you just simply construct a segment, or a line, but let's just do a segment between D and E, which is pretty cool, right? So I'll do it in blue here. So you just simply construct a segment between D and E. And so, ladies and gentlemen, this segment right here is actually a perpendicular bisector of segment AB. Okay? So we'll call that point C. Okay, so now we have a point C, right? And you can measure, you'll see that that's a 90-degree angle right there if you did it correctly. So there it is. You guys see that? So there it is. It's a pretty easy construction. Don't you guys think? It took longer probably the second time. Okay, so there it is. So there is how you construct a perpendicular bisector. Sound good, guys? Pretty simple. Okay, flip your paper over. let's practice one more time. So I want everyone to go ahead and construct and why don't we do it kind of diagonal on your paper just to make it a little more interesting. So go ahead and construct a new segment, okay? A new AB segment. And let's just kind of construct it diagonal in the middle of the page. Okay, so just construct a diagonal segment. And we'll call that segment AB. Notice you don't want to make it too long. Do you guys kind of see why some of you are too long? When you did that big arc, it was going to go off your page is what happened. All right, so don't make it too big. And let's just construct it. So we're not going to be too creative here. We're just going to call it segment AB again. Okay, so your job is doing it diagonally is to construct a perpendicular bisector of that segment on the back. Go ahead and do that right now. Okay, guys, with me on that? So tomorrow you guys will probably be back on headphones. Is that cool, guys? So, yep. So, yeah, Thursday and Friday off. And then Sansoni should be back by then. Tuesday, Nicely done. Some of you are very good at constructing. Very good constructing. You know, guys, the holidays are coming up. If you do celebrate, Christmas or whatever holiday that you get presents for, your birthday might be coming up. Hey, guys, ask for a really good compass for your birthday. I'm good. Okay. You got a birthday. You have your own compass, right? Okay, get yourself a nice compass, right? All right. When's your birthday there, girls? When's your birthday? Good, guys. We got some birthdays coming up. You get presents for your birthday. You got exactly what to do here, right? Okay. Are there any, Sophia? Wouldn't you want a compass for a present? Wouldn't that be nice?
No, I'd rather just.
If you knew some special someone and they got you a present, wouldn't it be nice to open a compass up with maybe some? But what if you got one that was gold plated or something? Wouldn't that be nice? Okay, all right. Are you guys good with that?
No. 90.5 degrees.
Xavier has a little human error going on there, right? Okay, put your white paper aside. Now I'm going to go back to my OneNote. Now I want you guys to construct a coordinate plane. So now we're going to go back to the coordinate plane, and we're going to play around with what we learned yesterday. Okay, sound good? All right, so let's go and do that. So now I want you guys to go ahead and get some graph paper. Now we're gonna play around with what we did yesterday. Okay. So first thing I need you guys to do is I need you to construct a coordinate plane. I don't know, maybe if you can do 10 in each direction, that would be great. If not, that's fine. 10 in each direction would probably be more than you need, but that would probably be good. Okay, so I'm going to go ahead and construct my coordinate plane, just like you are. Okay, our friend René Descartes is the guy who built this, right? So, all right, take this, move it over a little bit. So now let's do a little bit of coordinate geometry, what we learned yesterday. Now, we learned yesterday in the video, we learned about midpoints, distance formula, all that, right? Yes, Mr. Roden, we learned about midpoints and distance formula. Mr. Kahn taught us. Yep. Okay. So now we're going to do some geometry on the coordinate plane. Remember, guys, this is kind of modern geometry. Sometimes we call it analytic geometry. Okay, it's geometry on the coordinate plane. Okay, so coordinate plane lends itself nicely to geometric concepts that were around much before it was around. Okay, so here's what I want you guys to do. Give you a second. Let's go 10 in each direction. I'm going to have you graph 3 points, and then I want you to construct a triangle with these 3 points. Okay? So here's what I want you to do. I want you to go ahead and construct a triangle, and I have predetermined some points here. So I'll just write them over here. So point A, I want you to graph the point -2, 5. Hopefully I have this correct and I didn't make a mistake. Graph B, point B, I want you to graph the point 0, -5. Okay. And then part C, I got two, C, I want you to graph the point 3, 6. Okay, so go ahead and graph those 3 points, and then construct a triangle that create a triangle. Construct it, and use your straight edge definitely use a straight edge to construct your triangle. So go ahead and do that right now, and I'll do the same. Okay. So we have the point -2, 5. So left 2, up 5. 1, 2, 3, 4, 5. So that's A. And then the next point is 0, -5. So 0, 1, 2, 3, 4, 5. This is 0, -5. So this is part B, right? And then C is at 3, 6. So right 3, 1, 2, 3, up 6. 1, 2, 3, 4, 5, 6. And that's C right there. Okay. Now we're going to go ahead and create a triangle out of that. Okay. You guys with me on this? Undo. So do you all agree your triangle looks something like this? You guys agree with that? Okay, any questions? So does your triangle look like my triangle? Okay, now, what kind of triangle does this look like? Possibly, what kind of triangle do we have here? What's the possibility? Now, I see that Eliana has already done this, okay? So Eliana, I don't mean to pick on her, but she's made a pretty good observation, I think. Eliana has done this automatically. I don't know why she did it, but it's actually pretty good kind of intuition here. She put a square in that corner right there at A. Do you guys agree with that? Eliana decided she was going to put a square in that corner. Eliana, why did you put a square in that corner? Because it looks like a right triangle, right? Now, ladies and gentlemen, and she's a protractor. Remember, in geometry, a protractor is a measuring device, and so we can't say exactly. Maybe it's just slightly off. So how could we decide whether this is a right triangle or not? What can we do? Tanner? You could use the Pythagorean theorem and do a squared plus b squared equals c squared. Now, here's the problem with that. Finding a to c, that's going to take some work, right? Is there another way we could figure that out? Xavier?
Look at the rise and run of BA and AC.
Okay, very good. So if we look at so basically talking slope, right? So you're saying if we find the slope of B to A, right, and A to C, how will we know if it's a right angle?
If they're
Yep, and how do we know they're perpendicular slopes? What's the rule of perpendicular slopes, guys?
if they're
Opposite reciprocals. Do you guys understand that? In order for them to be a right angle, we have to have opposite reciprocal slopes. Very good, Xavier. Well done. So let's see if Eliana's intuition is correct. So what I want you guys to do is I want you to find 2 slopes for me. First of all, do we all agree that the slope of AB is a negative slope going down? You guys see that? Do we all agree that the slope of AC is a positive slope? Not very positive, but positive, right? So what I want everyone to do is I want you to figure out what is the slope, M stands for slope, right, class, of AC. or AB, sorry. And then I want to know the slope of segment BC. Okay? So I want to know the slope of those two segments. Not BC, sorry. AC. My bad, sorry. Now, you could do rise or run, or I hear what you're saying, Wyatt. You just want to look at the points, right? So yeah, I'll go down here. So if you just want to look at the points, because you're going to use the slope formula? Is that what you're going to do? Either one's fine. So yeah, you can use the slope formula. Since I have a graph and I can just simply do a rise and a run, it's up to you. So whatever you want to do, okay? So your job right now is to figure out what is the slope of AB and what is the slope of AC. If we have opposite reciprocals here of these two slopes, we know it's a right triangle, right? If it's not opposite reciprocals, we know it's not a right triangle. Okay. And have we covered that, or is that something you learned last year, opposite reciprocals? We covered that this year? It was in the delta math. Okay, I don't know, it was in the video yesterday, I don't know. So, all right, so that's why I'm talking to you in person. We can collect a little bit of the thinking here. Okay, so all right, so ladies and gentlemen, so let's take a look at this really quick. So who can raise their hand? I'll just take volunteers on this. Who can raise their hand and tell me what is the slope of AB? This guy, this Mamba Jamba right here. What's the slope of that guy? Rachel, what do you got? You guys agree -5? Okay, -5 over 1 or -5. I like that. Okay, what's the slope of AC, Wyatt? You guys agree 11 over 3? Kaylee, what'd you get? Positive 1/5. I like 1/5. You guys agree with that? Okay, what do you notice about -5 and positive 1/5, guys? What are those? Those are opposite reciprocals. So, Eliana, we have confirmed your theory that it's a right triangle, right? Okay, now, if it's a right, next thing I want to do is, so we can do a lot of cool stuff with this. First of all, we know it's a right triangle. So triangle A, B, triangle ABC is a right triangle. Now, guys, a right triangle is a super, super, super powerful triangle. You got to understand, whenever we have a right angle, that is huge. Right angles are absolutely incredibly huge in mathematics. Why? Because right triangles, we can use the Pythagorean theorem. Do you guys understand that? So, anytime the Pythagorean theorem can be used, it is an absolutely powerful thing. So, in math, if we can figure out right angles, that's really, really popular. Wyatt, what's up?
Isn't it actually like BAC because A is the middle point?
It doesn't matter. You can name it any way you want. Yep. As long as you use all three letters, it doesn't matter. Okay? Sound good? Yep. All right. So let's do this. So now let's figure out a couple things here. First of all, let's figure out the perimeter of this triangle. So what this will do, guys, is this will be a good practice of the distance formula. So what is the distance formula, guys? So if we want to take a look, now distance formula is something you should probably have memorized, or if you ever, next test, you probably definitely want to have this on your note card. Okay? So we want to always know the distance formula. Really, 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 really important application of the Pythagorean theorem. So what is the distance formula? Can someone raise their hand and tell me what it is? D equals, come on, ladies and gentlemen, we need to know this. Kaylee, what do you got? Very good, Kaylee. That is the distance formula. Guys, sorry. Yep.
It's important. It's very important.
Okay, it's very important. Yep, you're right, Xavier. Thank you. Okay, guys, this is something that we need to have. Distance formula is absolutely huge. Okay, it is a huge application of the Pythagorean theorem on the coordinate plane. Okay, so all this is just the Pythagorean theorem applied to the coordinate plane and a nice handy dandy formula. So your job, now notice guys, I purposely made this triangle so it wasn't perpendicular or vertical to any of the graph paper lines. So you can't just count graph paper lines. You have to use the distance formula because they're diagonal, all three of them. So you're welcome. You're welcome. All right. So your job, ladies and gentlemen, is to find three lengths, three measures. And if you want to round to the near, let's do that. We'll leave them as square roots, and then we'll put them in our calculator later. So don't take the square root yet. We'll do that after that. So I want to know in the square roots, you don't even have to simplify your square roots. Just leave them. I want to know what's the length, what's the measure of AC. I want to know the measure of AB. And I want to know the measure of BC. And guys, why didn't I put lines over those AC, AB, and BC? Why did I put segment lines over them? Because we're talking about measures, right? When I want just measures, I don't put segment symbols over the top. So your job, and just leave them as square roots, and then we'll just crunch them in our square root calculator in a minute. Okay. Well, Xavier has his calculator, so we'll use his. Okay. So remember, we're going to use points A, B, and C. We're going to use the distance formula, and we're finding the perimeter of this triangle. Have you guys found perimeters of triangles when you were little teeny kids, when you were in like 5th grade or something? Just distance around a triangle. Have you guys found perimeter of shapes before by just adding the sides up?
Yeah.
Good. So that's what we're doing here, right? Now we're going to do some math by democracy here. What do you mean by that, Mr. Roden? Well, because I'm not going to calculate it. We're just going to see what you guys are getting. And if we're coming up with a common answer, it's a really terrible way to do math, by the way, but we're going to do it. Math by democracy is we just take a common answer for each side, and we're hoping that, if we're all getting the same answer, probably correct, right? It's a really lazy way to do math, but sometimes you have to just be lazy when you have a clock ticking, right? Does everyone understand how to put these numbers in here? This is the video you watched yesterday, all that, right, guys? Okay, so does anyone have this? So they're going to all be square roots because we're not going to put them into the calculator yet. So the first thing we want to figure out is, does anyone have one of these measures yet? What do you got, Rachel? Just tell me which one you got.
For AC, I got the square root of 26.
You got the square root of 26. Did you get any other ones, Rachel?
For AP, I got the square root of 104.
104.
And for BC, I got the square root of 130.
130. Now, that would be the hypotenuse. The hypotenuse is always the longest side. So just looking at that, those numbers seem realistic and reasonable. Okay, just kind of let's do a vote here. How many agree with square root of 26 for AC? Okay, we're getting a lot of votes there. Okay, again, this is math by democracy. Terrible way to do math. Just don't ever do this, but don't tell people we're doing this. Okay, so how many got a square root of 104 for AB? Okay, don't vote just because you want to be Rachel's friend. Vote that you agree with it, okay? We got to agree with that? George, you agree with that? And what about 130? We agree with 130? Sophia, you truly do agree with that? Do you agree with it, Xavier? Wyatt, do you agree with it? Brady, do you agree with it? Okay, what do you think? Tegan, you guys agree with 130 up there? Okay, Kaylee, you agree with it? Okay, so it looks like enough of us are agreeing that these are the three distances we'll go with them. Sound good? All right, now we got Mr. Human Calculator over here. Square root of 26. Now, here, let's just see if my estimating skills are good. Square root of 26, okay, hold on. That is going to be approximately 5.1. What do you get? No, I don't. 5.09. approximately 5.1. So AC is going to be approximately 5.1, rounded to the tenths place. Usually distance of segments, I like to do tenths place. Okay, Xavier, you got your calculator for 104?
Yeah.
Okay, so square root of 104, I don't know this. I didn't, for real. So square root of 104 is going to be approximately 10 point, I'm going to say 10.1.
10.2.
It's off. Okay, 10.2. I thought about maybe 10.2. So AB is about 10.2, right? So this is going to be about 10.2. Okay, now this square root of 130 is going to be about, let's see here, 11. Hold on. 11 point, oh, this is going to be a tough one. So 121 and what is that, 144? Going to be almost 11.5. It's almost halfway between, right?
11.4.
11.4 what?
0.1.
I was off by another decimal. Okay, so this is about 11.4 again. Now, how would we figure out the perimeter, class? What would we do? You would add them up. All right, so go ahead and add those up, and that's going to give us our perimeter. Okay, see that?
26.
Okay, we all good with that, guys? So what is approximately the perimeter of this rounded to the nearest tenths place? What do you got? What's the perimeter, Kaylee? What do you got?
26.7.
Do you guys agree with about 26.7? Now, why am I going to put squiggly equal signs here? It's approximately. And now, what's the units? Well, they're just graph paper units, right? So we don't have to worry about that. Okay. All right. How would we find the area of that? How do you find the area of a triangle? This is good review. Dakota, how do you find the area of a triangle? If I want to figure out the area, how do I figure that out, Dakota?
The area is 1/2.
Very good, Dakota. 1/2 base times height, right? So let's figure out the area of this triangle. That's telling you how many squares are inside it, right, class? So 1/2. Now the base and the height. Where's the base and the height? What sides are the base and the height? What's the base? Give me a base, Dakota. Here's a hint. The base and the height always intersect at a right angle.
So 5.1.
Yep. And what's the height?
10.2.
What? Yeah, 10.2. And so the 11.1 is neither a base or a height. Does everyone understand that? You know it's a base and height because base and heights always connect, or they're always perpendicular to each other. Does everyone see that?
Yeah.
Why is that? Okay, so what is, ladies and gentlemen, I don't know why this is popping up, but it'll go away. What is the area of that? What is the area of that?
Rounded to the nearest 10.
Yeah, what is that?
25.1.
So there's approximately 25.1 squares inside here, right? 26.1? I don't know. I don't have a calculator. You guys?
My calculator says 26.1.
Okay, so
Yeah.
why it was. Okay, you guys with me on that? Okay, now, last thing. I want to know midpoints. Okay? So now the last thing I want to know is I want to know what is the midpoint of segment A. Oh, let's do BC. What's the midpoint of segment BC? So yesterday we watched a video on midpoints, right, guys? How do we find the midpoint? If I want to figure out the midpoint, halfway point between B and C, it's somewhere here, right, guys? Maybe somewhere about right there. How would I figure out the coordinates of the midpoint? Kaylee, what would I do?
Are you looking for the formula?
Yeah, what is the midpoint formula?
X1 plus X2 divided by 2.
Yep.
Y1 plus Y2 divided by 2.
Right, so if we want to find the MP stands for midpoint, it's really simple. All we do is just take X1 plus X2 and we divide it by 2, right, guys? That's going to be our midpoint X coordinate. And then we take our Y value, Y1 plus Y2, and divide that by 2. Sorry, it's going on my graph. And that's going to give me my Y coordinate of the midpoint. Okay, so if we're using BC, we're using BC, okay? We're using B and C, so we're using these 2 points right here. So what could we say that x1 is, class? 0 plus, what's x2? 3 divided by 2, right? And then what would be the y value? -5 plus 6 over 2. Y'all see that? So this is 0 plus 3 over 2. That's 3 over 2. Could we call that 1.5 just for fun? See that? Well, what's -5 plus 6? 1, right? Divided by 2 gives me what? 0.5? So let's just kind of graph that point. Graph that point really quick and see if that looks pretty good. Just kind of a visual. Does that look like that could be a reasonable midpoint? If you go right 1.5, up 0.5, right? Does that look pretty reasonable? Okay, put a point D there. Put a point D. Put a point D there. Okay, at the point, so at this point right here, go over 1.5, right? And then go up a half, right there, right? Now, if it's a midpoint, ladies and gentlemen, then in that case, if this is D right here, then BD should be congruent to CD, right? Measure them and see with your ruler. Are those measures pretty darn close? I'd measure in centimeters. What do you think? Do those measures look good? Hey guys, was this helpful today to kind of go over this stuff? I feel like we did a lot of stuff here. You guys see that? Okay, can you guys put your supplies away? Any work you have, you can keep, just put in your folder. Okay? Just know this is all testable material. I'm going to go ahead and end this. Screencastify. Okay, so Screencastify is